Section 1.4 is going to turn out to be very much like Section 1.3. In Section 1.3, we were given data, and we plotted that data, and what happened in Section 1.3 is the data should have fallen into a perfectly straight line. In Section 1.4, our data will not be perfectly in a straight line, but it's going to be close, and we're going to use a straight line to approximate. So, very much like we had the other day, the number of finishers in road races in the United States are shown in the following table for various years. So in 1990, 4.1 million people finished. In 2008, 9.2 million finished, so on and so forth. Let n be the number in millions of finishers in that year, that is t years since 1990. Create a scattergram and label the axes. All right, so what am I going to put on my horizontal axis? T, because it's time, and time is almost always the independent variable, and it's certainly the independent variable here because it came first in the table. So we're definitely going to have time here, and on the y-axis, finishers in millions. Okay, on my x-axis, my little tick marks, do I want to go 1, 2, 3, 4, 5?
You go 2, 4, 6, 8, 10?
2, 4, 6, 8, 10, or do you mean 2?
Like every other.
Okay, I think, so in essence you're going 1, 2, 3, 4, 5, but you're only marking 2, 4, 6, 8, 10.
Yeah.
All right, very good. Now, notice it does tell us that our year is 1990, and T is going to be years since 1990. Which means 1995 is going to be year number 5, and that's year number 10. Well, no, I think 2s are okay. So I'm going to do what you said, 2, 4, 6, 8, 10.
Is that going to work? Because we have
No, she meant for the I meant for the finishers. We have a Y. 2, 4, 6, 8, 10 on the Y.
Well, I wrote it in pen, so I'm stuck with it. Can't change it now. It'll work still. It'll work.
Will it? Because we have 1990 and 2000 and 2008. That's 18 total.
It's not going to work. Because we got to go 18 years away. All right, so 2, 4, 6, 8, 10 isn't going to work. Haha, I can fix that problem. See that? Start all over again. So, on our x-axis, going across, how do we want to go?
By 2 is both every line.
By 5.
Yeah, I did by 5.
So 5, 10, 15, 20 maybe? So I'm going to do every other one as 5. So I'm going to go 5, 10, 15, 20. I like to spread mine out. I like to use almost all the way across if I can. Y-axis.
That's what I was thinking.
2, 4, 6, 8, 10. Oops, and now I got to write this back down. I got to write time in years and finishers in millions. Okay, so I have 1990 4.1. Where's 1990 4.1?
Right on the N, just above 4.
Just right on the up and down axis, just above 4. That's correct. Right about there. And then I've got year 5, 6.0. So year 5, 6.0. Right there. Year 10, 7.4. So there's 7, so 7.5 roughly is right about there. Year 15, 8.1. And finally, year 18, which is right about there, 9.2. So does my data look like it falls into a perfectly straight line?
No.
No, but it's pretty close, isn't it? Okay, so what we're going to do is we're going to take our ruler and we're going to try to kind of draw a line that comes closest to the points. Now, I might not hit any of the points, and that's okay. So you notice I'm kind of making it so that my ruler is above some of the points, but at the same time my ruler is below some of the points. I'm kind of trying to average it out. kind of go in the middle of all the points. And I'm going to draw a line. Okay, so that's actually question B. Question B was draw a line that comes close to the points in your scattergram. There it is. Is it okay if your line hits some of your points? Yeah, that's okay. Mine, it kind of hits this one maybe. Comes close to these, but that's kind of what you want. You kind of want it sort of in the middle of the points, as close as you can get to all of them. Part C. Use the road race model, so that means use the line that you just drew, to predict the number of finishers in road races in 2014. All right, so 2014, am I giving you a year or am I giving you a finishers? A year, so that's one of the X numbers, isn't it? So when is 2014? If we started in 1990, 2014 is how many years later? 24. So T is 24. So I'm telling you 24 years. So you go to your graph, 24 years. Oh, looks like I might need to make my line just a little bit longer. Like so. 24 years is right about there. I go up. Looks like about how many?
11.
Almost 11. We'll call it 11. So let's see, what letter did they say to use for that? Did they give us the letter N? N would be 11. All right, then we have a new question. We weren't asked this in section 1.3. The new question is this an example of interpolation or extrapolation? Anybody know what those words mean? What's that?
Over guess, under guess.
No, not quite, but you're not far off. Okay, interpolation means the value you ended up with is that within your original data. So our original data went from 1990 to 2008. Is 2014 within that span? No, so it's not interpolation. So what is it? Extrapolation. So what is, if interpolation means in the data, what does extrapolation mean?
Outside the data.
Outside the data. So this is an example. T equals 24, N equals 11. Both of those values are outside of the data we were originally given. So this would be extrapolation. Outside of the data. Use the road race model to predict which year there will be 10 million finishers. Okay, what am I giving you this time? I'm giving you N, aren't I? I'm giving you number of finishers, and we want to find T. So this time I'm telling you N equals 10. So if N is 10, I come here and I come across right about there. Then I go down, 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 down. Looks like about how many years? 19, 20. I think both of those would be reasonable answers. Which one do you want me to use? 20 years. So T equals 20 years. In other words, we started in 1990, so 20 years later would have been 2010. Is that an example of interpolation or extrapolation? Extrapolation. How come?
Because it's not listed in the data.
Well, it's not that it's not listed, it's that it's
Outside the 20 years.
it's outside of what was given. So if our answer turned out to be the year 2006, we would have said that's interpolation because it fell within our data range. But 2010 is out here, it's past the data. You can't see what I'm pointing at. There we go. 2010 is out here past the data, so again, that's extrapolation. What is the n-intercept of the model?
1.1.
Again, we write intercepts as points, though, so it should be 0,
0, 4.
comma 4.1. What does it mean?
That's where the Oh,
In 1990.
In 1990, 4.1 million finished road races. Is this an example of interpolation or extrapolation? This one is interpolation because it is inside of the data we were given. That one would be an example of interpolation. Questions on that? The other thing that shows up in this section, it didn't show up in this problem, is something that we call model breakdown. Anybody have an idea what model breakdown means? Model breakdown means you get an answer that doesn't make sense. For example, what if I asked you in this problem, what happened in the year, let's say I picked the year 1920. Well, where is the year 1920 on this graph? It's way back to the left. And when I come way back to the left here, I got to go back how many years? 70. That's a long way, isn't it? Where would this line be? It would be
It'd be underneath the X.
it would be underneath the x-axis, which means I would get a negative answer. Would a negative answer make sense in this problem? Would it make sense to say negative 5 million people finished a race? No, that would be an example of model breakdown. You would get an answer that doesn't make sense. Okay?